Hi class, now we will continue with Chapter 1 Introductions of Communication System. Previously, we have teach about the definitions, the importance of the communication systems, message, information and signal, and we also see through the video about the history of communication system. Okay, today we will go through the basic components and requirements of the communication and etc. Okay. What is the basic requirement of the communication system? Normally, what you do is when you play your handphones, you think that you must have very fast transfers of the information, which means you can download the picture very fast, download a song very fast, and you play the game, don't be delayed. So the first thing must be the rates of information transfer. Second is the purity of the signal that you receive. Okay. The signal received is same with the signal transmit. For example, you having a call with your mom. You must think that this call must be clearer and what your mom talk about and you listen is the same thing, right? Okay. The third one is the simplicity of the system. Nowadays, we need the simplest system, the better. Last time, we have a phone like this. Okay. Nowadays, we need a handphones like this, a small size handphones. The last one is reliability, which means the quality being transferred is trustworthy. All of the performing consistent as well, which means the quality that you receive can be believed. You don't want that something you talk in phones is very secret but can be listened by the other, right? Okay, this is the 4 main basic requirements. Okay, next one. Element of the communication system. In the communication system, we will have the informations and audio video data received by the transmitter TX, and this transmitter will pass through these informations or the signal through a communications channel or a communications medium. This medium can be wireless, okay, or wire, or our optical fiber optic cable, or a free space like radio, okay, and etc. And in this medium, the noise is happening, and this noise will disturbing your signal. Okay, and this signal later on will be received by the receiver RX, and this signal will be recorded, become information or intelligence. Okay, this is the general model of all communication system. Okay, the first element, information. What's the information? Information, which means exists to convert a message. So message come from the information source. So the information can be audio, video, or any data. And this information can be analog, like our voice, phones, video, audio, or in digital form, in a range of frequency they can occupy. Okay, and transmitter. What is transmitter? The process input of signal to produce a transmitted signal that should to the characteristic of the channel. So inside the transmitter, we will perform the modulations, coding, mixing, and translate. For example, we will amplify the signal. For example, when you have a sound that you receive by the transmitter, it will amplify first and filter and only send through the antenna. Okay, the message covered into the electrical signal by the transducer. For example, the speech are converted into a voltage variation by a microphones. Transmitter are made by the oscillator, amplifier, tune circuit, filter, modulator, frequency mixer, and frequency sensitizer, and other circuit. So this part we will teach you in chapter 2 for the detail. Okay. Channel. Communication channel actually is a medium where the electronic signal is sent from one place to another place. For example, atmosphere. Okay, we have fiber optic. Okay, we also have the electrical conductor, and etc. Okay, so the signal undergo the diffractions from the noise and interference and distortions. Receiver. Okay, receiver is to recover the message signal contained in the received signal from the output of the channel and convert it to a form of suitable for the output of transducer. So what happened in receiver is we will have mixing, demodulations, and decoding. Other functions perform like amplification and filtering. And transducer convert the electrical signal input to a form and desired by the signal used. And the receiver, we contain amplifier, oscillator, mixer, tune circuit, filter, demodulator, or detector that recover the original intelligent signal from the modulated carrier. So this one we also will touch in chapter 2 in detail. Okay, when you have receiver and you also will have transistor. Receiver is to receive the information. Transistor is to transmit the information. Okay, transceiver, which means you can transceive the information and receive the information. It's an electronics unit circuit that both can send and receive the signal at the same time, like your telephones, okay, and like our cell phone, and also like the fax machine. You can transmit and receive the fax, and like the handheld CB radio, like the modern computer modem, you can transmit and receive the signal. Okay, what is modulations? So these modulations will be happens in the transmitter. Okay, modulations process is impractical to propagate the information signal over a standard transmissions media. Okay, which means it like a puzzle. Like you want to send something, you must put inside a puzzle, only you can send out, right? Okay, inside the modulation we have a signal called carrier signal are used to modulate the source of information. So which means we are putting something into the puzzle to send out. Okay, and into a higher frequency analog signal. So this process is changing one or more property of the analog carrier in a propagations in a proportions to the information signal. One of the characteristics of the carrier signal is to change according to the variations of the modulating signal. So this is the equations of the modulations. So in chapter 4 we will study about amplitude modulations, AM, and also we will study about the frequency modulation, FM, and we also will study about the phase modulations, PM. Chapter 4 and 5. Okay. why we need the modulations? The advantage is to generate the modulated signal suited and compatible to the characteristic of the transmissions channel, and is easy for easier radiations reductions of the antenna size, and reduce the noise and interference, and channel assignment, and increase the transmission speed. Okay, this is the modulations happen in the transmitter. Okay, for example, now we are talking in front of a microphone. Okay, this microphone will record my sound. Okay, it will become a signal, and this signal will be amplified, go through the amplified, become louder, and we will call, here we will have the bass band signal. So this bass band signal, it will go into the modulator where the modulation happen. So we will have the this one is the oscillator. So this oscillator, high frequency carrier oscillator, will generate the high frequency carrier. Okay, when it generate the carrier, this carrier will combine, or we say as modulate the signal, this signal, bass band signal, become the modulated carrier signal. Okay, this signal we will go through the power amplifier, we amplify it again before we transmit the signal to the antenna. Okay, this we want to amplify it before we transmit because we want to reduce the noise when it happen in the communication channel. Okay, so we will have some type of modulations. Okay, this one is the amplitude modulation, and another side is the frequency modulations. Amplitude modulation, which means we modulate the signals based on the amplitude, the height of the amplitudes. So you can see our amplitude height become bigger and smaller and bigger, and based on the size of our actual signal. So this one is the signal. Okay, I can show you here. Okay, this one is our intelligent signal. Okay, this one is our intelligent signal. Okay, okay, this one, another one. Okay, another one. Okay, another one is this, the sinusoidal unmodulated carrier. Okay, so this one is our carrier, you see. Okay, okay, this one is our carrier. Okay, so from here, for this one is AM amplitude modulations. For the B is the frequency modulation. Okay, we can see here, this one is a sinusoidal modulating signal. Okay, our information signal. Okay, this one is our carrier. When we combine the carrier and the signal, it will change based on the frequency of the signal. So we see, suppose it to be the same, then it change, become far away, closer, far away, closer, far away. Okay. They vary based on the frequency. Next one is multiplexing. Okay, for multiplexing is a process of allowing two or more signals to share the same medium or channel. So for example, we have three basic type of the multiplexing. We have frequency deviations, time deviations, and code deviation, which means these three things, they can share two or more signals together at the same channel, and transmit receive happen at the same time. Okay, this one is the multiplexing at the transmitter. So we can see from here, we have the multiple baseband intelligent signal. So 1, 2, 3, 4. All these 4 signals, it will go into the multiplexer, and at the same time it composite or multiplexed. These 4 signals become a signal, become one signal, and this signal undergo modulations with the carrier signal, okay, generated by the oscillator, and transmit to the power amplifier and amplify the signal before we transmit to the antenna, and this antenna transmit out the signal. Okay, this is what happened about the multiplexing. Okay, the next one. So after chapter 2, we will go to chapter 3. Chapter 3 is about noise. So what is noise? So this is noise, which means it's the unwanted signal that contained with the desired signal. So which means we have our desired signal, it contaminates the noise and make our signal become unclear. And they have 2 types of noise, like internal noise and external noise. What is internal noise? Internal noise is the internal device components in the circuit. For example, like when we record something, they have the sound like disturbing our voice. External noise, like the noise generated outside the circuit. For example, the atmosphere noise, solar noise, cosmic noise, and man-made noise. So man-made noise, like when I'm talking, someone like disturbing me. Okay, this one is man-made noise. Okay, what is interference? Interference is the contamination of the extra news signals from the human source. So from the other transmitter or power noise, a power line or machineries. This occurs most often in the radio system, whose receiving the antenna usually intercept with the several signals that at the same time. Okay, one type of the noise. Okay, then next one we have distortion. So what is distortion? Distortion is the signal or the wave perturbations caused by the imperfect response of the system to the desired signal itself. It may be corrected or reduced by the help of equalizer. Okay, so these 3 things we will learn in chapter 3 later on in detail, and about the calculation everything. This is just the definitions. Okay, next one is the attenuation. Signal attenuation or degradation exists in all media of the wireless transmissions. It propagates to the square of the distance between the transmitter and receiver. Okay, this attenuation, which means that loss of the signal, or we have loss of data, loss of power is a loss. Okay. Limitations in communication system. Although communication system is good, but they have the limitation. For example, first one is the technological problems, like the equipment that were available nowadays, and the economic factor. Like for example, last time we have the Nokia phone, the 2G phone. Nowadays we have the smartphone, smartphone, something like this. So this is, last time is a limitation. So because of the limitation of this big phone, cause the speed becomes slower because of the limitation technology. The improvement of the technology, we will have the faster rate of the communications. And problem can be solved in theory, but perfect solution might be not practical. Okay. The next one is physical limitation. Okay, for example, the bandwidth limitation, measurements, the speed, the system ability to follow the signal variation depend on the transmission's bandwidth, and available bandwidth determine the maximal signal speed. So which means we have the limitation on the bandwidth of the signal itself. Next one is a noise limitation. Noise limitations normally is unavoidable, like the kinematic theory, or the noise relative to the information is measured from the term of the noise, of the term of signal to noise ratio SNR. Okay. Next, we will talk about frequency and wavelength. Okay. In frequency and wavelength, we will talk about cycle, frequency, periods, and wavelength. Okay. What is cycle? Cycle, which means one complete occurrence of the repeating wave, or a periodic wave like this. Okay, periodic wave. And this wave will be repeated and repeated. And they have the one positive and one negative alternation, such as this signal sine wave. Okay. Then what is periods? Period, which means is one period, the time distance between one point, this is a point, it is one point, to another point, a similar point, which is similar point on a periodic wave. So this one we call as one period. Okay. Then we will talk about frequency. What is frequency? Frequency is the number of cycles of a signal that occur in 1 second, which means the frequency equals to 1 divided by t, the time per second. Okay, so this one is t. Okay, now we will talk about the frequency and the wavelength compared. Okay, this one is the time, or we can say is the period. And what is the wavelength? Wavelength is lambda. We call it lambda. So which means the distance traveled of an electromagnetic radio wave during one period. So this is one period. Is one period, and the lambda or the wavelength happen in one period. So we call as the wavelength. Okay, in terms of distance. Okay, calculating the wavelength and the frequency. Frequency and wavelength. So we will have this formula: wavelength lambda equals to speed of light divided by the frequency. So the value of speed of light is 3 times 10 power of 8 meter per second. So we substitute this value into the speed of light. So we will get lambda equals to 3 times 10 of power 8 divided by frequency in meter. So we will get the lambda is in meter. Or we rearrange this frequency, we will get this equation. We will get the frequency equals to 300 per lambda, and we will get the frequency in megahertz. Okay, now we given an example. What is the wavelength if the frequency is 4 megahertz? So lambda equals to speed of light divided by the frequency. Okay, speed of light is 3 times 10 power of 8 divided by the 4 megahertz, and we will get 75 meter. So this is our wavelength. Okay, very simple, right? Now we go to the magnetic spectrum. Okay, in the communication, signal will be transferred through the magnetic signal. Okay, so the most slow signal, or we can say is the extreme slow signal, we will have the Earth subway signal. Okay, this signal, geomagnetic signal source. Okay, and we will have the extreme low frequency signal, which means like from 3 Hz until 3 kHz, the wavelength. Okay, this one is extreme low frequency, like the AC power. And then we will have very low frequency, and from 3 kHz until 30 kHz, and this one is the slash monitor. And we also will have low frequency, medium frequency, high frequency, very high frequency, and ultra high frequency. This frequency we known as radio frequency spectrum, like the mobile AM FM, okay, our radio, or our televisions, or our cell phone. Okay, then we will have 3 GHz until 300 GHz, we known as super high frequency. Okay, super high frequency is the microwave, like the satellite and microwave. Okay, then we will have infrared 300 GHz until 430 petahertz. Then we will have the visual signal, the spectrum, which means our light. Okay, then we also have ultraviolet. Our visible is our sunlight. Then we have ultraviolet from 750 petahertz until 330 picohertz. Okay, then we will have the ultraviolet signal. Then we will have X-ray signal, medical X-ray signal. Okay, then the gamma cosmic ray signal. So this one is the radioactive source. Okay, this is the electromagnetic spectrum. And we also have the optical frequency. Optical frequency, which means like infrared. We can be see 0.7 to 10 micron. And we also have the visible light. Okay, the sunlight 0.4 to 0.8 micron, and we also have ultraviolet light shorter than 0.4 microns. Okay, what is micron? Micron is a millionth of a meter. The light wave are measured and expressed in the wavelength rather than frequency. Okay, we also next we go to the frequency spectrum and bandwidth. Frequency spectrum of a waveform consists of all frequency contained in the waveform. Their amplitude plotted in the frequency domain, so known as frequency spectrum. Bandwidth of a frequency spectrum is the length of the frequency contained in the spectrum. Calculate by subtracting the lowest frequency from the highest. Okay, what is bandwidth? Bandwidth is equal to a difference between the highest and the lowest frequency in the signal. Okay, bandwidth of the communication channel is different between the highest, same thing, highest and lower frequency of the channel allowed to pass through it. So this happens in the communication channel. Okay, communication system design. The next one, we go to communication system design. So during we design the system, we will look on the transmission time and the power, and also the signal to noise ratio performance. We need the lowest noise performance, and the cost of the equipment must be cheaper, and the channel capability, and also the bandwidth of the signal. These 1, 2, 3, 4 issues will be considered during our design. Okay. Next, I will talk about the signal. Actually, we have two types of signal. One is analog signal, and another one is digital signal. Analog signal is the very continuous variations of the voltage of the current. Okay, you can see in the picture, variations of the current and voltage. Okay, assume the total range of frequency per time, or information transmitted like TV, radio, and voice. Okay, then we also have digital signal. Okay, digital signal is instead in discrete increment, translation 1 and 0 in binary. So we can see in telegraph, okay, the Morse code, continuous wave, WC code, series binary code in using in computer. Okay, you can see 1010. Those things are digital signal. Okay, inside the picture. Okay, and between the analog versus digital signal, we also have the digital communication system and analog communication system. So in the digital communication system is inexpensive, and they have privacy protected data encrypt, can be merged the different data and error corrections. This is the advantage. The disadvantage is they have the larger bandwidth and synchronization problems is relatively difficult. For the analog communication system, they have the disadvantage where it's very expensive and not privacy per se, cannot merge with the different data, no error corrections and capability. Advantage is they have smaller bandwidth and synchronization problem is relatively easier. So this one is the advantage and disadvantage of the communication system. Okay. Okay, this slide also talk about the analog communication system and the digital communication system. So analog, so we will look on the energy transmit and receive in form of analog. Okay, for digital we will cover the digital transmissions, like the digital radio and through digital system, and refer between two or more points in the communications, and also we requires the physical facility like between the transmitter and receiver, and we also have digital radio transmissions digitally modulated the analog carrier between two or more points of the communication system. Okay, we also have another type of the communication system, which means is simplex, duplex, halfplex or fullplex communication system. Okay, what is simplex? Simplex is one way. Like for example, you can from the transmitter, you transmit the data and receive just one way. Okay, duplex, which means you can transmit and at the same time you can receive the signal. Okay, simplex you can see like TV, just transmit, you just receive is simplex. Duplex, like transmit receive, like computer, okay, like handphone, telephone, transmit and receive. And half duplex is alternate transmit and receive, the transmitter and receiver. For example, okay, like the walkie-talkie, you just can transmit the signal, another person listen. Okay, after that you need to press a push button, then another person it talk back to the person A. Then when person B finish talking, the person A will push a button and talk with the person B again. Okay, one person talk at one time. Full duplex. Okay, full duplex is the simultaneously transmit and receive. Okay, which means they can transmit and receive at the same time. It's full duplex. Okay, so what is simplex? Okay, you can see FM, AM broadcast, TV, radio, okay, cable, television, fax machine, okay, wireless, remote control, and etc. Okay. Then duplex, you have telephone, two-way radio, radar, and metro radio, citizen radio, okay, family radio service, internet, the WAN, wide area network, LAN, the local area network, and etc. Okay, this one is duplex. Okay, various form of communication system. We also have the broadcast radio television system. This one is the broadcast communications, and we also have the mobile communications like telephone 1G, 2G, 3G until 5G, and transmitted a fixed communication system by the landline, and we also have the data communications like the internet. Okay, that's all for the chapter 1. Thank you.